We are going to talk now about transport layer protocols. Transport layer protocols. Okay, so we've moved down. We're no longer dealing in the application layer. All right, everything we've talked about has been at the uppermost layer of networking. Now we're moving down. The packet is beginning to be ready to. I'm sorry, not the packet at this point. The data is beginning to be made ready to send onto the network. So the transport layer protocols are responsible for a couple of different things. Depending on the protocol you're talking about, the transport layer is responsible for reliability and flow control. We've talked about how Ethernet is a best effort delivery system. It just sends it and hopes. Ethernet functions at the lowest layer, okay, of networking. So the reliability aspect of it is handled at the transport layer of networking. Okay, so what the transport layer does is it uses a header to identify the application layer of a chunk of data. Okay, it also breaks large chunks into smaller chunks. That's known as a segment, so that data can be sent in a frame that is no larger than 1,518 bytes. Okay, we know that that is the maximum Ethernet frame size, and in fact that maximum frame size is used by a number of different networking technologies. Okay, so at the transport layer, data is broken up and reliability takes place here. So let's look at some protocols. So this actually has, what does this actually say? Supply a field, so that's identifying the application layer. Provide reliability and flow control for applications that typically transfer a large amount of data. Okay, so flow control, reliability, that's all talking about getting data from point A to point B in an effective way with the least amount of errors. And if an error does occur, retransmitting. Okay, so there's two protocols that function at the transport layer. They are TCP and UDP. You need to know the difference here because it's really important. We've talked about so far, we've mentioned at the application layer different protocols at the application layer. They say, some of them say TCP and then port number and then a port, right? Where some of them actually say UDP, a port number and then a number, right? So TCP is a connection-oriented protocol and designed for reliable transfer of information in complex internetworks. What that means, in a nutshell, is it is all about making sure data gets from point A to point B reliably. It's connection-oriented, meaning it makes sure that the data is reliably transferred. Okay, it maintains a connection, maintains an open channel of communication. Where UDP is connectionless, it's much like Ethernet is best effort delivery. This is just best effort. Good luck on your journeys. Don't forget to write. So UDP is not concerned with establishing a connection first so that there's a reliable communication. It's concerned with getting things from point A to point B in a quick way. So you'll notice that there's several things that utilize UDP. DNS is one of them. You want your DNS lookup to be very quick, right? And then HTTP, which is what would follow DNS in a lot of instances, you'd want that to be reliable more than quick. Okay. Oops. Sorry, just dropped my lid there. Both actually break data down into smaller chunks, either segments or datagrams. Often datagrams don't have multiple chunks that would go together to make a larger chunk. Segments are typically smaller pieces of a bigger puzzle, where datagrams are the entire puzzle in one contained unit. They don't require segmentation. They aren't required to be broken down because they're self-contained. They don't need to be any smaller. So datagrams would be, in the case of like DNS, there is no need to break it down into a smaller chunk. Where segments often, if you're, for instance, if you're transferring a file using FTP, the file might be 1 gigabyte. You can't transfer 1 gigabyte in a stream of ones and zeros. You have to break it up because of lower technologies that can't handle large chunks. Okay, so a segment is broken up data, essentially. Provides a means to identify the source and destination applications involved in a communication. The means is addressing, known as a port number. Okay, so a port number identifies a source and destination application. And that's done in a number of different ways along the path, and we'll look at how that works. We don't really delve into all of the specifics of how port numbers work in this chapter, but we do delve into how they help to identify stuff. So we've talked about several application layer protocols, and there's, for instance, like with HTTP, that's associated with port 80, right? And so that stuff, that's because that port number at the transport layer identifies that the segment is an HTTP segment. So your computer knows how to process it. That's what it's for, essentially. And then they protect data with a checksum, much like a checksum that would be used in a frame trailer. Okay. Okay, so the units of data that the transport layer work with are TCP and UDP, of course, segments for TCP, datagrams for UDP. Okay, they both add a header to the datagram or the segment, so they both get a TCP or a UDP header depending on what protocol is being used at the upper layers. Okay. Then the transport layer protocol passes the segment or datagram to the internetwork protocol IP. Okay. With incoming data, the transport layer receives the segment from the internetwork protocol, processes it, de-encapsulates it, and sends the resulting data to the upper layer. So de-encapsulation happens at this layer as well. Encapsulation would be adding that TCP header and sending it down, de-encapsulation, receiving it from the network protocol and stripping the header and sending it to the appropriate application layer or the appropriate application layer protocol based on the port number. Okay. So I've mentioned this identifying source and destination applications is done through the use of port numbers. This is how computers keep track of multiple data streams coming in and out. They use port numbers for that. So when you have a web browser, an email application, chat, and word processing program, they're all running at the same time and they're all accessing resources on a network. How do they keep track of all that incoming data? Of course, port numbers are what's going to do that. So they use destination and source port numbers for that purpose. Okay. So destination for sending to a specific application, source for when it comes back, that's going to be the destination on the new segment or datagram that responds. Okay, TCP and UDP use port numbers to specify the source and destination application layer protocols, of course. So port numbers are 16-bit values assigned to specific applications running on a computer or network device. If you calculate it out, 2 to the power of 16, because we have 16 bits total, is 65,534 or something, 536 maybe. I can't remember exactly the specific, but it's about 65,000. And that's how many port numbers there are. Okay. And a lot of them, not all of them are assigned to specific tasks, but a lot of them are. And we went over a few. None of them, I should say not all of them are assigned to specific applications or application layer protocols, but many of them are. So of course TCP and UDP provide a checksum similar to the CRC. Intermediate devices do not recalculate this checksum. Intermediate devices only look at the frame checksum. Okay, so intermediate devices might get an error packet and discard it, or an error frame and discard it. They're only concerned with that checksum. The end device on either end of a transmission are what checks the transport layer checksum. Okay, they check every checksum, but also the transport layer checksum. Okay. So TCP is the reliable transport layer protocol. The point of it is, the way it's reliable is because it establishes a connection using system known as a three-way handshake we'll look at. It segments large chunks of data down into smaller sizes, smaller segments that can be sent across a network, and it ensures flow control by requiring acknowledgments after so much data is received. So an acknowledgment has to be sent back that says, hey, I got that data, before it will send any more data. So a sending end will wait for a response from a receiving end. So that in that way it's connection oriented, right? It's maintaining a communication that says, hey, we're good, continue transmitting, okay? So it establishes a connection before data is sent and only ends that connection when data transfer is finished, okay? Or if the connection gets broken. Okay. A client, so I mentioned this is done through a process known as the TCP three-way handshake. The process is essentially this. It's a SYN packet. It's a TCP, a specialized TCP packet that gets sent from a source that's trying to send data from point A to point B. That's known as a SYN packet. That establishes the connection initially. Then the receiving computer responds with an ACK-SYN that acknowledges the synchronization. Okay, and finally a SYN-ACK is returned. So SYN, ACK, and SYN-ACK. That's what it is. Sorry. I apologize. It's SYN, synchronization packet, an acknowledgement packet, and then finally synchronization acknowledgement. So it's like this. If I'm going to do a little drawing. I know you guys love my drawings. So we've got a source PC, and we've got a destination PC here. And let's not even confuse ourselves with the intermediary network, because that's irrelevant at this point. Okay, so the source is going to send SYN packet, synchronization packet. This just says, hey, let's get on the same page. I want to send you something. Okay. Okay. This guy is going to respond with an ACK packet, acknowledgement. And finally, I know I'm kind of doing this backwards and upside down. So this is the first step. First step, second step. The last step is a SYN-ACK. Okay. So that's known as the three-way handshake. Okay. So, I'm sorry, it's an ACK-SYN. I'm sorry. Don't get too confused on that. You just need to remember the three-way handshake is how TCP establishes a connection. You don't need to necessarily remember the specific details, though when you deal with security, you find that there's a special type of attack that hackers use where they essentially send a bunch of TCP synchronization packets or TCP SYN packets that they never respond to, and that actually opens up a bunch of channels of communication on a server and can bring it down. So essentially if you keep doing it over and over and over again, you're going to prevent a lot of users from being able to access that. So essentially you just need to remember the term three-way handshake and remember that that is how TCP establishes a connection so that that data can be sent reliably. Okay. There's also another type of special packet. This is a reset packet. This is if for some reason the connection gets refused or the transfer of data needs to be reset for some reason or another. So, okay. So the whole purpose of segmenting data, TCP will recognize that lower layers, and does recognize that lower layers require smaller chunks of data, smaller segments, in order for files to be sent on a network. Okay, UDP doesn't actually do this because most things that are sent with UDP, like I mentioned before, are self-contained. It's not sending large chunks of data typically. So in order for data to reliably get from point A to point B, and then reassembled on the right end, it uses segments that are labeled with a sequence number. Okay, that sequence number tells it when it gets to the receiving end 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if you segment it down into, let's say 10 segments, each one's going to get a sequence number that says this one is number 1. So if it came in first for some reason, if the path that it took on the network was faster, and then the next one comes in out of order, so let's say 2 comes in before 1, that doesn't matter because the transport layer is going to reassemble them into the correct order before it hands it back up to the application layer. That's why you can download a large file that's maybe several gigabytes, maybe several megabytes over a network that's using Ethernet frames and a maximum of 1,518 bytes, or 1.5 kilobytes if you want to think about it like that. That's not that much. So you can transfer quite a bit of data in that way. Okay. So TCP also uses a means of regulating the amount of data that gets sent, known as flow control. So only a maximum number of segments can be sent before a reply that says, hey, we're good, we're still connected, must be sent back from the server. So an acknowledgement that says essentially something to the effect of, hey, I got all that stuff, we're still connected, I'm still here, I'm still listening, go ahead and transmit the next chunk of data. So a window size is what's known as is what's used to define the maximum amount of data that can come through before it's going to require an acknowledgement to send any more. So your sending station, your source, is going to send, after it does this three-way handshake, so this is next, it's going to send so much data over, and then it's going to require an acknowledgement back from the destination, your server, or whatever, your destination device, whatever that is, that says, hey, I got that data, go ahead and continue to send me more. Okay, and that's known as flow control. That process is known as flow control. Okay, so we got a couple of questions there. And that is it for this video. Next one we're going to talk about is the internetwork layer. I should mention really quickly before I stop, we're just below 20 minutes, but before I stop, UDP does not utilize any of those reliability measures that I just mentioned. So segmenting data, of course, doesn't happen with UDP because it's self-contained. Establishing a connection using a TCP three-way handshake does not occur with UDP. Okay, and finally, window size is not a concern with UDP. It just sends it. Flow control, I should say, is not a concern with UDP. It just sends data in a self-contained UDP UDP datagram, and ultimately a UDP. I guess it would be a frame at the end of the day. So that bears mentioning, I think. So UDP does none of the reliability measures. So when it talks about TCP being the transport layer protocol being the protocol that's responsible for reliability, that would only apply in the case of TCP and not UDP. Okay, so I'm going to stop right there, just under 20 minutes, and I will finish up this last video, and we'll call it a day.